Okay, I'd like now to ask David King to come and join us. David is the head of technical for Syngenta in the UK, which means he's responsible for the technical direction of the company in this country. He tells me he's passionate about using a storytelling approach to help agronomists and growers understand how products and services can help improve both their yields and the quality of the crops that they produce. And as I said earlier, he's going to come and talk a bit about what Syngenta is doing to address themselves and to help their growers address the challenge of climate change, and look at some of the specific solutions they're working on in the UK. So please again give a warm welcome to David King.
Thanks, Carl. Thank you to all of you for coming here. It's a great pleasure that Syngenta are sponsoring this, and we're delighted to do so and to introduce people to some great science. I have to have a confession here, I'm not a great scientist. So I'm talking about, in a forum, talking about climate change, and it's an area I don't know a massive amount. But what I do know a lot about, or some about, is about UK agriculture and growing, and I understand where Syngenta's position is. So as Carl was saying, what I wanted to do is to introduce a little bit about what Syngenta's approach to climate change is, and what we think about, and how we're looking to invest, and what we're hoping to do. But also then to take that and to give a few examples of the sort of things that we're looking at and how they apply to the UK. So that's what I was aiming to do. So just a few things on climate change and agriculture. I mean, just a few things about the key issues. It's about the changing weather as far as we can see. And a key part of that, as far as agriculture is concerned, is what is happening to water and the differences and the things that happen when we have climate change and affect where water goes and what happens with that, and the availability of water. And that has great impacts both on land and soil quality, and we're also looking at stresses as well. We're trying to grow plants to feed the world, and when we have stresses on those plants, then that can have some great impacts on the efficiency of those plants. So we're looking here at the requirements for crops and cropping systems really to provide food. And as we know, we've got two challenges that are coming towards us and happening right now. One of them is about population growth and feeding the world's population. And on top of that, then we have an issues in terms of climate change as well. So changing climate factors will affect crop growth, but also from a Syngenta point of view, it's how they will affect pests. In terms of pests, we're talking about insects there, diseases and weeds. Because as the climate changes, then we may have select for different organisms that will challenge the crops that we're wanting to grow. Now, if we think about the stresses and the environmental stresses that are increasing, here's a map that was drawn for a Syngenta meeting, but I think it's pertinent here. We're looking at where we're estimating the impact of climate change to be, and the red areas are where we particularly think of high impact, and the orange areas are on the medium side of things. And if we look at where agriculture is, the big parts of agriculture around the globe, you can see, by and large, they're going to be affected by climate change. And we know that agriculture uses something like 70% of the world's freshwater withdrawals. You know, so if we've not got water in the places that we want it, then that potentially gives us some issues. The other thing, as I mentioned, about population growth and climate change happening at the same time, back in the 1950s, we were looking at, for each hectare of land, we were looking at feeding just 2 people. What we're estimating into the 2030s, for that same hectare of land, instead of feeding 2 people, we're looking at that same hectare of land having to feed 5 people. Now that gives us some major challenges, because we've got more stresses and strains on the crops that we're wanting to grow, but we have to become much more efficient as well. So what is Syngenta doing, and what's our approach to things? Well, we're also a manufacturer. And so one of the things that we do is we take our pollution profile seriously. And to give you one example, we have a site in the UK at Huddersfield, and I was told that our site in the UK in Huddersfield, that we've reduced our greenhouse gases on that site to 20% of what we were producing in the 80s and 90s. And that's an ongoing thing. not only does it make great sense from an efficiency point of view to do that, but as far as our responsibility. Now, I'm not a production scientist or an engineer, so I can't really answer many more questions about that, but other than that, we're taking it seriously. The bits that actually I'm involved in is looking at helping farmers be able to produce crops more efficiently. As we mentioned, if we have to grow food for 5 people on each hectare of land, we have to do that much more efficiently. And Syngenta is interested in making sustainable intensification. So those areas of land that we can grow great crops on, to do that the best. And it's beholden on us to find ways to help farmers to maximise the yields that they have on those areas of land, but to do it in a sustainable way. Now, this is a slide that was produced for a Syngenta Investor Day of a number of years ago, but I think it's a useful slide to give an idea of how Syngenta is looking to be able to invest in innovation around abiotic stressors. So if you look at the blue circle there, that's our estimate of the total economic value of dealing with the traditional ways that a crop protection company would function. Dealing with biotic stressors, with weeds, with insects, with diseases, having people involved in regulatory, and managing resistance. If you have a look at the orange circle, that's what our estimate is going to be about future needs in terms of dealing with abiotic stressors that will come around from climate change, from constrained natural resources. As the population grows, those resources will potentially diminish, but also having a responsible attitude in terms of polluting into the future will constrain those resources, and input factors, and also things such as major pest shifts. So from Syngenta or a manufacturer's point of view, this is an area of great interest to us to invest and to look at finding these solutions. And we started to look at potentially, going from a 300 billion needs to 900 billion into the future. So there's great opportunities that we see in this as well, on top of our responsibility from a stewardship point of view. So what's our approach then from a UK point of view? Well, I'm a quite simple person, and I kind of look at it and think, well, the approach really is that if we have stronger, healthier plants, they're more likely to be able to cope with adverse conditions. And if you think about the UK, it's not a secret we've had some very extreme weather for the UK over the last few weeks and months. We had one of the driest winters and early parts of spring. We've just had some very, very hot weather just now. So plants in the UK, we think of it as a benign climate. But actually, it's a climate where our plants have to deal with a whole load of different conditions. So what I'm going to give you is some examples from a crop protection point of view, how we can help plants to be healthier and stronger, and also from a varietal point of view, because Syngenta is both involved in a crop protection side of things and also from a plant breeding point of view. Now, if we start out on the crop protection things, I just put this up. This is an advert for a new seed treatment that we've just launched into the UK. Now, the reason why I'm showing you an advert is not to get you to all buy lots of our material. We'd love you to do that. But I think it's a great example of a change of view and a change of perspective in how we should think about things. We are guilty, as our industry, as only looking at the top parts of plants. We only tend to view the foliage because we can see it. That's the bit we can feel as farmers and as people involved in the industry, such as ourselves. You can see that, you can measure that, it's very easy. The bit that's neglected in all of this, of course, is the roots. And one of the things with our seed treatment, and it's been specifically developed, it has an effect on improving the rooting of those cereal plants that we apply it to. And in future, it's going to be on other major crops as well. So not only does it help to deal with the seed and soil-borne diseases, but also it has a root boosting benefit. And to give you an idea of this, this is some photographs from a trial that we have in Nottinghamshire. And what you can see, here's a leading standard here for seed treatment. And as you can see, with our new seed treatment, we can see an improvement in the amount of rooting that's going on there. And we can measure those, and as we can see, we can have some quite large improvements, both in root weight and the plant weight above the ground, and then when we add those two together. Now, by doing that, we have a plant then that's better able to deal with the adverse conditions that maybe it will have. And the reason why I'm showing you this little photograph here, this is what we call a mini rhizotron. It's a small child's toy, really, where if any of you had, as children, wormeries, where you put worms in soil. This is effectively a wormery. But what we have is our seed treatment here on the right and the nearest standard on the left. Now, what we did here was we grew these plants in this little wormery and gave them a level of soil. And it was part of an experiment that we had with our launch of this material. What we did is we asked the people who came to the launch to be able to plant lots of their little plants like this. We've asked ADAS to then go away and to take the roots from this and to do some analysis on it. And Roger and Daniel just there would be probably familiar with the results of this. Now, we've seen some improvements in rooting, as you've seen with the other photographs. But we put this little experiment and we set it up in our office and we just left it. In fact, we forgot about it, to tell you the truth. We were quite feckless. We just didn't bother to water it for a while. But it's a brilliant example of how plants can deal with stress when you set them up to be healthier plants. Because what you can see, these plants are in the same soil medium, there's no difference in the soil, there's no dividing in there. They had the same amount of water at the start. What happened was, we just didn't bother to water them after it. But what we can see is the plant that had the better root structure was able to deal with the adverse conditions that it had. And we can see this actually in the field. We've had some hot weather just recently, but if I take you back to the 3rd of July 2015, it was the hottest July day on record in the UK. I think it was getting up to something like 40 degrees Fahrenheit, centigrade, somewhere around there. It was a really, really hot day. And what we noticed on the plants after that day, when they were put under extreme stress, we noticed that the plants that we had with our seed treatment, the vibrant seed treatment, ended up with more chlorophyll. And we could measure that with a chlorophyll meter. So we asked Nottingham University to do some studies to try and understand exactly why we were having those effects. And just to take you back to sort of a biology lesson here, you know, this is all about photosynthesis. So what we can see on the top graph here is a healthy plant. And with a healthy plant, if you increase the light intensity, you increase the amount of photosynthesis that goes on, the excitation of chlorophyll. And you can see that measured. Now, no plant is 100% efficient, so the little red dash area there is the delta between what it could capture and what it actually does capture. Now, we know that when we put plants under stress, whether they're old plants or they're drought stressed or temperature stressed or nutrient deficient, that photosynthesis is nowhere near as efficient. So what we want is light to go into photosystem 2, we want more sugar production. The bits it can't use, it gives off as chlorophyll fluorescence or non-photo quenching, basically it's heat given off. And what we were able to see at the study in Nottingham University was to try and put these plants under more stress. So what we have is an untreated plant here with 90% of the water it needs and our treated plant. And really there's no difference between those plants. If you look at the plants on the far right and the far left, you can see there is a difference. The ones that had a better rooting structure and a better, happier, healthier plant were able to deal with that drought stretch much better. And when we then look at being able to, the amount of CO2 assimilated, what you can see is that when you look at this graph, there's just one line there that stands out. And it's the line with the little dots on it, the round white dots. That's the line that had untreated at 10% of the water it needed. All of the other lines are pretty much the same. So what we could see, that even when we had our vibrance treated plant here with Sedaxane, it was exactly the same as those plants from a chlorophyll point of view, a photosynthesis point of view, as the plants that were getting more or less the water that they needed. So why was that happening? Well, in that study we did some multi-array analysis, And what we were able to tell was that some genes were upregulated and some genes were downregulated. Now, for those who aren't familiar with this, basically, if you downregulate a gene, you get less expression of that gene. If you upregulate it, you get more expression of that gene. It's like turning the knobs on an amplifier up and down. And what we were able to see, when we look at this table here, we're able to see that when we look at those genes that are associated with stress biotics and stress signaling, you can see when they're treated with vibrants, less of those genes are downregulated. There's less expression of them. If we look at the genes that are associated with protein synthesis, i.e. the growth of the plant, we have an upregulation of those. What we're basically doing is we're stopping that plant doing what it's trying to do biologically when it's being put under stress, is shutting down. What we're trying to get that plant to do is to do more of what we want it to do, is to produce proteins and to carry on growing. So how can we use these benefits? Well, there are various different things that we can do. If we have happier, healthier plants that go on and get established more often, then we're better able to deal with things like this weed here. And as UK growers, you'll probably recognise it, and it's blackgrass. And of course, one way of being able to control blackgrass is to plant it later. If we plant plants later, what those plants have to do is to get established faster, quicker, to be able to be better plants, to be able to deal with whatever's thrown at them in the future. Of course, we're better able, if you have a bigger plant, you're better able to deal with pests, for example, slugs that would be attacking those, because you've got more biomass there to be able to cope with those. And if you had seed beds that are more cobbly, for example, you're able to deal with those. Sorry about the joke, everyone. And of course, we've had some pretty benign winters of late. But it wasn't so long ago we had some very, very harsh winters that challenged our agriculture. So if we have a better established plant as we're coming out of the winter, then we can deal with that better. And of course, dealing with drought. So what we're looking to do here is to be able to produce as high a yield as possible, but it's about dealing with risk and finding ways of being able to manage those crops to reduce the risk. So that's an example from a crop protection point of view. If I move on from a plant breeding point of view, the truth is, when we breed plants, every year is different. And if you give some examples of that, from 2016 down to 2013, we had some very different years. We need to be aware of that when we're doing our breeding, because what we need to be able to do is not just select a plant that gives a good yield response in one year. We need to produce those phenotypes that can able to produce a consistent yield year on year. And that's what we've tried to do in Syngenta. Now, one of the breakthroughs that we've had in terms of producing consistent plants is to be able to look at hybridization. Now, hybridization has been used in many crops around the world, but not so much in cereals. It's quite hard to produce hybrids in cereals. One of the reasons because of that, is that cereals tend to pollinate themselves. So Syngenta have been at the forefront of developing hybrid barley, and as I'll talk on a little bit later, also hybrid wheat. But what hybrid plants are able to do is to have bigger, stronger root structures that can then support bigger canopies later on and help them to deal with adverse weather conditions. And when we look at the roots, what we can see here with our hybrid plant versus a conventional barley, you can see a bigger, stronger root structure. Something like 70% more root length is what we have. That allows a plant to be able to exploit so much more soil. And I know Roger and his team have a passion about this in the M projects, looking at being able to exploit more of the soil. It allows you to get better nutrient use efficiency, so be able to make the most of the nitrogen that we're putting on. Again, producing nitrogen contributes to greenhouse gas, so it's beholding on us to make the most of that, and also better water use efficiency. And to give you an idea about that, what we're looking at on this table here is the amount of seasonal rainfall. So we've got from greater than 800 mils over here to less than 700 mils. Now, when we look at the difference between our hybrids in the blue graph to the conventionals in the yellow, we can see that we have a yield improvement over those, even when we have reasonable levels of rainfall. When we have less rainfall, we can start to see that hybridization and the exploitation of those roots into the soil to get all that they can out of it, we can start to see that really kicking in. You can see a much bigger difference between the yield improvement versus the conventionals when everything's going for them to when they start to get into more difficult conditions. And when we look at HGCA, or AHDB as they are now, recommended list trials, this was from 2007 to 2012. What we're looking at here is the control mean along this x-axis here. So it's the yield in tonnes, so from 5 tonnes to 12 tonnes. And then what we're going to look at is the difference, percent difference from that control mean. If we look at our hybrid barley, what we can see here is when yields are poor in the control means, we have a big improvement there. So when conditions are more adverse, we see a bigger improvement and a more consistent yield. And if we compare that to the next leading standard at that time, which was cassia, we can see that hybrid barleys are better able to exploit those situations that are much more variable. And you can see that there. So my final few slides is looking at where we're looking at in the future. So hybrid barleys, we have them in place now. We are on the breakthrough of being able to produce economically efficient hybrid wheat by the same process. And of course, wheat is a much bigger crop around the world than barley, and a much more economically significant crop. And those same benefits we see in barley, we expect to be able to see with hybrid wheat versus hybrid barley. Again, it's about being able to make the most of the conditions that you have to produce the highest yield possible. Finally, I just want to give you an idea about the philosophy of Syngenta. One of the things that we wanted to be able to do is to have some measurable things that we could put in place that would show our commitment and to be able to develop our commitment to the agricultural community or the world at large. And we call it the Good Growth Plan. And if you go online, you'll be able to see information of the Good Growth Plan. But there's a couple of bits in this that relate really to this topic. And it's about making crops more efficient. There's a commitment to that. Rescuing farmland. You know, there is no more farmland out there. We have to make the most of every bit of available farmland that we have and to have it in as good a condition and not exploit it. So we have a commitment within our Good Growth Plan to help to restore 10 million hectares of degraded farmland. We're looking at increasing biodiversity. Increasing biodiversity is good for the things that we're wanting to do, but it's also good for the crops that we're trying to grow. And we're looking at enhancing the biodiversity of up to 5 million hectares of farmland around the world. And many of you from the UK will have seen our efforts around Operation Pollinator and the pollination strips that we're working on. So those are the things that we're looking to do. So just to summarize, you know, we know that climate change will impact on the social, economic and environmental systems around the world, and particularly on people. And food production and delivering food to the world is absolutely vital. You know, we have to be able to produce more from less land, and that means efficient use of the land. But it also means that we can't degrade the land that we've got. It means about adapting our agricultural techniques to limit potential damages, but to cope with increased food demand, and to all do that without harming the environment. And Syngenta, I hope, are at the forefront of bringing the science of that to UK agriculture, but also around the world. So thank you for listening to that. That's the end of my talk.